Hello and welcome back to the MAT live stream, but this week interviews. It's great to see so many people here live, and it's great to see so many people in chat. Chat's actually going a little bit too fast for me to answer questions. I've tried to answer the questions before we go live. Didn't manage to keep up. Lots of questions. So the about the offer rate. Oh my goodness! Right. Okay. Let's do frequently asked questions, just because I can tell people are stressed, and I want people to be less stressed. First, if you are waiting for an email from your college to tell you if you're shortlisted or not, please don't stress. I can't say the word shortlisted. Please don't stress. Some colleges are waiting until they've done loads of planning around the interviews before they send out the emails. They should send them out by the end of this week or at the very start of next week. I was just talking to a college on the phone to find out if they're going to do their emails tomorrow, please. They know who they are. I don't know if they're watching the stream. Hi, David in chat. Hello, anonymous people in chat. Other things people are stressed about. If you've got an email from your college telling you that you're shortlisted, but not saying when your interviews are yet, congratulations, you've been shortlisted for interview. Your college has sent you this placeholder email so that you're not stressed like that previous group of people I mentioned just now. But they are also doing all the planning around when they're going to do their interviews this week. So they've sent you a notification to let you know, but please don't stress. They're also doing all the scheduling at the moment, and they should get back to you basically at some point during next week to let you know precisely when interviews are. I am also interviewing, and I know vaguely when I'm interviewing, but oh, goodness me, it's complicated. There's a lot of people on a lot of time zones. Let's do some FAQs from chat. No, let's read chat a tiny bit. We got the tree up, 30th of December, so it's pushing a little bit, but you know, that's what we're up to. Does that say what are you doing on the board? Like my whiteboard behind me. Planning things mostly. Don't worry, nothing to do with admissions. Significantly. Why did you say significantly more instead of giving a percentage? This is something I said in chat. They asked how many people have been shortlisted, and I said significantly more than normal. I answered that because I didn't want to give a percentage. Hooray! If I've learned anything over the last 2 months, it's the value of a political response. I don't normally do that. I'm sorry. I've been politicized. And somebody else is then confused because does that affect how many offers we're making? And that doesn't affect how many offers we're making. We're interviewing a few more people than normal, significantly more than normal, but we're making the same number of offers at the end. The offer rate overall, applicants to the number of offers, is unchanged. Somebody asked quite a complicated technical question about if they reapply, then there'll be fewer interviews. So does that mean that it doesn't affect how many offers there are? So if you apply in the future, then the admissions process might be different, but there you go. Yes, David asked about time zones. We are aware of time zones. We are usually quite good about planning around time zones. There was a survey at one point. You can start to imagine how complicated it is for tutors. My Miro board just switched off and on again, but I'm hoping that's going to stay there. Same for computer science. Or I think everything I've said so far is the same for computer science in terms of scheduling, timetables, when they're doing emails. They've significantly shortlisted more people than normal. I'm pretty sure they have. I don't actually know. So one of the reasons not to give a precise number is I don't actually know. I haven't checked. Computer science have also separately changed how they report on that one. Okay. What's the best way for a student to prepare? Yeah, these are the sort of questions that I want to do today. What's the best way to prepare? Now, you've actually asked about a Year 12 student preparing for the MAT, so hi, welcome to the MAT livestream. You are presumably preparing for MAT next year. In general, applying for maths at university, the best things you can do are to practice problems, to practice getting stuck on things. They don't have to be the same problems that you're going to be doing for an entrance test for that university, but just practice getting stuck on things. And that's also something that's people are going to be practicing for interviews, because almost certainly during an interview for maths, you'll be asked some sort of tricky maths question and you won't know what to do straight away. You'll be, maybe briefly, maybe for a while, stuck. The difference for an interview compared to a test like MAT is that for an interview, the interviewers can help you out. and they can give you hints and sub-problems. That's part of the fun. It's a little bit like the tutorial here, the small group teaching, that the tutors can give prompts and can help people out, teach you at the end of the day. People are learning. So people say worried about further maths and interview syllabus, and good news or maybe bad news, there's no interview syllabus. There's no list of maths topics that you are required to know, because of that reason I just mentioned, that interviewers can help you out. I'm going to show you some interview questions later on today, and some of them are clearly based on A-level maths topics, and some of them kind of aren't, and that's okay. I don't want you to have the impression that you could just read all of the further maths textbook and then your interview would be easy. That is not what's going on here at all. And if you've already done maths and further maths and you're getting ready for your interview, I'm afraid it's not going to be, what did it say on page 20? Well, all know that maths is more interesting than that. Yeah, I think it is significantly more for all of the maths, joint honours and CS things. Technically, my main, the courses I watch the most are maths and philosophy. Yeah, so elaborate. What do you do if you're stuck? Yeah, what do you do if you're stuck? So I have this as a kind of who, what, where, when, why, how kind of set of questions. I get asked about interviews quite a lot, and I think you can sort the questions into a kind of who, what, where, when, why. 3, 4, 6. That's only 6. Like, why is this happening? And I saw someone in chat say, like, what's the point of your admissions process? That's not quite what they said, but you know. When? We've had a few when questions already. Who? And how on earth am I going to do this? How do I prepare? What do I do if I'm stuck? And I have that over here in the kind of how section, I think. Okay. Hey, people looking from LinkedIn comments. If we're asked a question that includes some theory we haven't seen before, should we let the tutors know? Yes, absolutely. So ask for clarifications if you're not sure. So my classic example of this is if the interview says something like this question is about a function with f of x equals this, and you're thinking what's a function, because in your school they were all called strictly mapping functors or something, I don't know, then you can say what's a function, and they can explain what's the thing where you put a number in and you get a number out, and that's not part of the assessment, that's just us trying to make sure we're speaking your language mathematically. Loads of people from Lincoln in chat. I would do some talking as well. So this is one of my talking points here, and I don't want a question mark on it. This is genuine. I don't want a question mark on it. You should have questions, but you don't have to put a question mark on your advice for questions. You have already prepared is a kind of important thing. You already, already, tiny earthquake there. Let's not forget, you've been shortlisted for a maths interview because you're good at maths, and you've already done several maths questions before, up to many, and those are all helping you prepare for seeing some new maths questions. You've applied for an MSc by research, and you'd like to know about the interview process for that. I have absolutely no idea. To be clear, today I'm only going to talk about undergraduates, because the undergraduate interviews are about a week and a half away. Sorry. Probably some of the stuff I'm saying applies, but I only work on undergraduate admissions. I'm really sorry. Let's just quickly flag this. Hello, viewers on YouTube watching the replay. I didn't put undergraduate in the title. Maybe I should have. For graduate stuff, it's going to depend which graduate course you've applied to. Maybe look carefully at which graduate course you've applied to. Good luck. Okay. You should get a rejection email. Sorry, not should, but your college shouldn't leave you hanging. Your college should write to you to tell you whether you've been shortlisted for interview or not. Oh my goodness, look at the chat. Am I good at maths? What if I find out during the interview that I'm dumb? I found out during my interview that I can't simplify fractions. I thought I could. I went in very confident, went in hot on those fractions, can't simplify them to save my life. I had 5 to the power of 4 over 6 to the power of 4, and I very, very cleverly crossed out the 4s, same thing top and bottom, to simplify. That haunts me to this day, but somehow I still got into university and studied maths and did a PhD, and now I'm on the other side of the webcam telling you about it. So if I can be stupid, maybe you can too. Deadline to hear from our college. No deadline, sorry. They really should, in my opinion, email you by the end of this week. Or maybe at the start of next week. But start of next week would mean you spend the whole weekend waiting for the email. I mean, you shouldn't worry because it's not going to come over the weekend. Should be tomorrow. How are you going to stand out? How can I stand out? Oh, very nice, okay. I mean, it'd be good if you were good at solving the maths questions. If you told me things that was clear you had an idea about how to handle the problem. That's a good technique, by the way, for interviews, kind of in general. Instead of launching into the very detailed thing, is to give a kind of big picture first. When people say, where do you see yourself in 5 years? Oh no, so let's not do other interview questions because it'll get confusing. My rejection seems wrong based on the info, and I consulted past admissions officers. Interesting. They agree. Oh my goodness. Is there any way I can request a review? No, sorry. You can make an appeal in January if you believe there's been a procedural error, but you can't make an appeal based on academic judgment. I'm sorry these other admissions officers, you know, would have made a different academic judgment, but that's not grounds for appeal on its own. Really sorry, but I have to be firm because it's the academic integrity of my colleagues. Okay, yours came at 19:30. Somebody's working late. Don't tell me which college. Oh, good, it's an anonymous person. Haven't received a rejection nor an invite. Yeah, just don't panic. Don't be scared. Just wait. Let's go. Let's go. Don't panic. I forgot to ask you how your day's going. Should we do the poll now? People who join new, we do the poll. Do the poll of how your day's going, so I can find out if people are having a good day or a bad day. I never really know what to expect when I switch this on. Well, let's read chat a tiny bit. Do you get access to MAT scores even if you haven't applied to Oxford? Yes. If you apply to Warwick or Imperial, then you can request your MAT score from that university as part of their normal admissions feedback process, which I think happens at the end of their round in March. That's probably not the response you wanted, but hey. Last year you wore a jacket and looked very smart in the live stream. Why not this year? Wow! Happy now, chat? Hello, welcome to the MAT livestream in a suit. People want to know if I'm going to interview them. I'm on an interviewing team. It's not obvious to me whether I'm interviewing everyone at a particular college or just some people at the college. It's confusing. Good. With the max, people still want me to set a deadline on colleges. Bear in mind, this will not make you happier. Because if I set a deadline for colleges to email you, one of two things happens. Either one, the college just emails you like they were going to anyway, so I haven't improved matters in that case. Or two, the college emails you a little bit afterwards and you get very, very, very nervous. I've misled you. Right, okay. The tree is nice, isn't it? It's its second year. Anyway, we've got distracted. We were talking about how you're going to do this. How are you going to do interviews? I think the thing I really want to stress, just while we're doing this vote on how's your day, the thing I really want to stress is that you've already been preparing for this. It's not something new. It's not like surprise, 100-meter time. Tell me how fast you are. It's just more maths questions, which you like, right? You like that. Okay. That's a reference to one of my students. Shout out to Emily at New College. Hi, Emily. She told me that one of her interviewers, to try and make her feel comfortable at the start of an interview, tried to have a conversation about running, and to try and make her feel comfortable, asked her what her 100-meter time is. And I think that's a classic example of a mathematician trying to make people feel comfortable, but I don't know if it worked. I have a different policy. My policy for interviews is that I never ask about anybody's personal statement ever. If at all possible, I try to only ask maths questions. That's what I want to do. But that's me just telling you my personal policy. Some of my colleagues like this. Interviews are mostly 11. Let's do when. I can see a when question in chat, so I'm going to go when. People are stressed. People are stressed both ways around, but let's not be stressed. Let's not be stressed. Let's do a when. And people are having an okay day, right? That's 4 or 5 stars, but loads of 1 stars, which I think is the stressed people. Quick multiply. There's about 7 really stressed people in chat. Why don't I ask about personal statements? I mean, two reasons. One, I already have your personal statement. If I want to read it, I can read it. If it's got your 100-meter time in, I don't need to know that. Secondly, I found that people relax more when you just start talking about maths. We'll do a maths question in a bit, and I promise you people will calm down a bit. Or not calm down, but be less stressed if there's some maths on screen. This kind of external chat, it doesn't calm me down, and I'm not sure it calms down anyone else. So mostly Monday the 11th to Thursday the 14th of December. Disclaimer, this video was recorded in 2023 and I'm talking about Oxford and I'm talking about maths and or computer science. I guess that and or could be the word or in nice capitals, couldn't it, for computer scientists. Other years, maybe other dates. There are some, because people get stressed when I say this and imagine that it's going to run forever. Some on the previous Friday for overseas. ICU, people in other time zones, possibly the previous Friday, but we try to give you lots of notice for that. Please don't stress. It's going to be okay. If I forget what partial fractions are, brilliant stuff. There's no, I say interview deadline. People are trying to make me set a deadline on my colleagues, and I haven't. Sorry, I'm not going to make up a deadline on a live stream. That's not fair on anyone. How are scores compared? That's kind of an important question. Let's go with that. So Jed, the Oxford way of doing this, we have some shortlisting advice that was written for colleges that doesn't directly compare MAT scores with the additional test scores. We didn't expect them to have the same average or the same variance or the same granularity, and we didn't expect that the tests would be taken by necessarily the same group of people more exactly. So we tried not to compare scores like for like. I mean, one of them's out of 100 and the other one's out of 10, so what are you even going to do there? Instead, we had a kind of two-stage system, which I'm really not going to say very much about because I want to talk about interviews. But we put a lot of care into it rather than just, anyway, never mind. You're 9 out of 10, that's good. Yeah, Mat B, why are they calling it Mat B? It's only one question with follow-ups. Multiple questions, yeah, that's a what question. Let's go what. During the day, if this is not obvious, I don't know. I mean, we try our best. We've got some applicants in Australia and New Zealand. I see you. Hello. It is currently, gosh, plus 13, so it's currently 30 o'clock in New Zealand. And 30 o'clock is not a reasonable time to have an interview. So we would try and work something out there. What? So, usually about 25 minutes and about 2 questions. That are usually ramped, which means that the difficulty gets harder during the question. I'll give you some examples later on, very soon now, don't worry. Usually ramped so they get harder along the way. Oops, I'm writing beneath chat, there we go. What does doing well on an interview look like? I mean, doing maths, right? Do some maths questions with us. Oh, you told 30 to 40 minutes? Usually, thanks Miles. Some colleges might do more or less. Probably not much less. What are my slots like this year? Never mind, okay. So usually 2 questions, maybe with 2 interviewers taking in turns, or maybe 2 parts of the interview, but it's hard to say because they're usually ramped up in content along the way. And it's usually 2 interviewers, 1 interviewee. I mean, that's fixed. We don't do group interviews, at least not for maths, or or computer science before you ask, but oh gosh, I have no idea what's going on in other subjects actually, which also does over here. 2 interviewers. Now there's different setups that people do. So these might be tutors, they might be lecturers, they might be graduate students who've done some training. Actually, I mean everyone does some training, but I'm especially making it clear that the graduate students who have done some training. Look, if there are any graduate students watching, I'm not trying to single you out, but I'm trying to tell the others that you've done some training. The email. This is the classic. This is classic, by the way. Sorry. The email your college sent will include rough timing, says Anonymous. Now that varies from college to college. Some of them don't. Sorry. And okay, I get one of you. Back to what? People over here. I'm bouncing around. It's good fun. Usually you get. Usually, how many of these you get? Usually, at least 2 for maths at Oxford and for computer science at Oxford, and for maths and computer science at Oxford. Usually at least 2 at least 2 colleges. And that is usually, we do our best. I think in maths, the last time I counted, it was more than 95% of people were getting interviewed by 2 colleges. And most people were getting more than 2 interviews overall between those 2 colleges. I've missed a word there. There we go, just a number. Will we be expected to have a calculator with us is a new question for me. I would never assume that somebody had a calculator with them. I have once, usually during an interview, I've got a calculator with me just in case, in case that things go in that direction. If you haven't been told to bring a calculator, don't put any thought into it. Right, good, okay. I think anybody who's saying what their MAT B score is estimating. I don't think we've released enough information. Are you allowed A-level formula sheets? I'm going to say no. This is not like, I mean, this is not really like an exam. You have 1 or 2 interviewers. I put usually 2. 1 or 2 interviewers right there who can help you out. They're not interested in your ability to look up a fact. They're not that interested in your ability to memorize a fact from A-level. The interview question, what is a cone, would be terrible. What's the volume of a cone would be awful. Okay. Gap year questions. There's no policy of asking harder questions to gap year students, although when I show you the questions, it'd be clear that I can ramp them up. So, you know, if you're great at solving questions, then hopefully I get to see what it's like when you're stuck. I haven't done where, which is maybe worth saying, online. Again, this video is being made for the University of Oxford in the year 2023. The current plan for Oxford is to do online interviews for the time being, which means at the moment in 2023, a mix of Microsoft Teams calls and Miro whiteboards. And there's an asterisk on this one. Not all colleges are doing this. Other colleges might be just talking to you or getting you to scribble on a bit of paper and hold it up to a webcam. Other colleges might be just talking to you about a maths problem that you can do out loud. Other colleges might be using Miro. I don't know why I'm saying other colleges at the start of each bullet point there. Colleges might be using Miro, which is the whiteboard software that we've been doing the MAT live streams in. Hooray! It's an online whiteboard thing. Don't stress about it. Some people would have preferred in person. I don't know. Isabella's just got a Durham offer, so congratulations to Isabella. Have I ever had a student who gets stuck on a ramp? Yeah, I think it's happened a little bit, but usually my questions have got a horrible, horrible ramp. How do we use the whiteboard if we don't have a stylus or Apple Pen? If you don't have anything that can draw on the whiteboard, let your college know or let your interviewers know. If you think your college has invited you to a thing when they're planning to use Miro, let them know if you have nothing that can write on the whiteboard. It's actually still helpful for you to be able to access the whiteboard, or failing that, we've got this like tier of backup options, right? Failing that, someone can do a screen share, a bit like I'm doing now, where the interview question appears in front of you and you can at least see it. Failing that, I can hold up a bit of paper to the screen and we can do it like that in Teams. If all else fails, contact your college to say, look, you've invited me to an interview that uses tech. I'm worried about the tech. Is there anything you can do to help? And if your college has shortlisted you, they want to interview you, willing to do some effort. Will they think it's weird if our Miro username is a bit unusual? I don't think you have to log into Miro. I don't think you need to make an account. I'm not certain. I'm not certain at all. I should not comment. I'm not certain. Anonymous person has got the same graphics tablet and pen as me, so I gave you the brand. Which, gosh, looking at it now, it's actually quite scratched. I can read maths on it. I must have had a really angry maths session at some point. When are the interviews? Mostly the 11th of January, the 11th of December to the 14th of December. That's for Oxford Maths and Computer Science. This is fun. I can now just whip around the board. Somebody said, is it okay to be silent for 20 seconds? And I think it is okay to be quiet. Obviously, your interviewers don't know what you're thinking during that time. You might like to say something like, let me just think about this, or okay, let me think, as a communication device, right? So that tutors know that you're thinking about the problem. Now, I've met a lot of students who would like to be left alone to think. Occasionally, if somebody's been thinking for a long time, I do need to try and prompt them to say something or write something so that we've got a record of what they're thinking and what the progress is. If you're thinking anything at all, I would like to be able to join in, I think. It's sometimes the case, I know, that students want to kind of solve the whole problem or check whether something works before they say it out loud, out of caution. But it's totally fine to say what your idea is, and then we'll find out together whether it works or not. And it probably does. And that's also faster, usually. For example, you say, I'm wondering if I can use integration by parts, big pause, and then I say, and what will the parts be? And you say, I have no idea. And I say, yeah, me neither. Let's not do integration by parts, let's try something else. And between us, we've saved, what, a couple of minutes there of just thinking about integration by parts. I would not use a mouse to draw Miro. I would not try and use Miro with a mouse. This is one of the things. We found that if your school or college has something you can borrow to write on, I don't know, maybe it's worth asking. I would not try and use Miro with a mouse. For comparison, here's my handwriting using a mouse. Oh, this is not too bad. No, this is pretty bad actually. It's also very slow. And I've got just not a very good graphics tablet that, if nothing else, lets me write a lot faster. And arguably my handwriting is worse, but it's faster and a little bit smoother. If I tried a bit harder, which is what my teachers always used to say. Normally the percentage of people who get interviewed is 30%. Now Flynn, that number changes if we get more applicants. We've never promised to interview 30% of people, because what if everyone applies? 30% of 8 billion is quite large. I think of it in terms of people per place. How would a maths? Oh, sorry, I've missed your question. Maybe you'll stop saying it if I. Maybe you'll stop saying it if I answer it. How would a maths and CS interview go? That is the whole point of this session, right? Still just maths question, or more question 6 style questions? Yeah, obviously they're going to ask you about your interests, or ask you about the topics that you're applying for, right? You're applying for maths and computer science. They're going to ask you questions about that sort of thing, right? Question 6 on the MAT is a great example of what Oxford thinks the intersection between maths and computer science is like. So a good place to start. You know, obviously, if you've applied for physics or something, please don't spam chat asking about the concept of physics. We're going to be all right. Okay. Dress code. No dress code. Please wear whatever's comfortable for you. I've put a jacket on, but that's just because chat told me to. that's just a separate joke we've got going. Okay. Love you, chat. Let's do a quick why, which is something like, so we want to see you solve problems. That is the most honourable reason to do an interview, that you want to see someone succeed. We want to see you get unstuck. So getting stuck and then getting unstuck. Now that one doesn't sound quite so honourable, because to get unstuck, you have to get stuck. So that one sounds a little bit less, good, but I do want to see it as well. Interviews are interesting because they're about, they're a mini exercise in kind of like learning and working, thinking. There's a tiny bit of arguing, tiny bit. There's like a lot of problems that go into that you can fit into an interview question. Cool, let's not get too aggro as well. Okay. How do you solve the Bernoulli integral? Is that the setup to a joke? Sounds like the setup to a joke. Will be tested on year 2 content. I'll show you some content, and then you can tell me whether it's testing you on year 2 content. The tutors don't think of it like that. The tutors don't sit down and say, what content have they learned? Can we check they've learned it? The tutors sit down and think, let's ask about some maths. What's an interesting question? So this is not a test of how well school is going for you. School is going very well for you. And whether you're doing A-levels in this order or in parallel, fine. Maybe that means you haven't seen or you have seen some content. But school is going well for you. We don't need to check how school's going. So we don't need to ask you about just stuff that's happening in the classroom. Instead, we can do these kind of problem solving things. I think I am almost ready to start talking about maths questions. Someone's watched these before and now they're watching one live. If you're watching one live, that means there's a chance that your comment gets read out on screen. Finally joined one live, smiley face. Is there stats and mechanics? I get asked this so much. Shall I show you a mechanics question? I could do a mechanics question. Let's put it on the set list. So I know that A-level includes mechanics and statistics, and for you that's like a separate chunk of mathematics that you're maybe not so keen on compared to the further pure chunk of maths. Tutors don't think like that. The separation and the units that you're doing is kind of an artificial construction for A-levels. Tutors generally don't think in terms of A-level units. So a question might have a kind of real-world framing, or it might have a kind of mechanical component, but remember that they can help explain things to you. I've got a question that involves kinetic energy, but if you can't remember what kinetic energy is, I can help remind you, and that's going to be all right. Yeah, mechanics question. Cool. What if I get asked a question that includes theory you haven't seen before? Yeah, you should let the tutors know. It's kind of unlikely in a way that a question would be easy if you know some particular theory. I mean, I suppose everything's easy if you know enough theory, but I mentioned integration by parts there, and that's sometimes tricky because it's sometimes tricky to use at interview because you don't really know if people have learned integration by parts. I think probably everyone's learned integration by parts by now. Okay, my Miro board is sort of connecting and disconnecting, but it seems to be quite fine overall. I never learnt discrete maths. Will I get asked on it? Literally, I think I could ask tutors here, and maybe half of them would be able to say what's in A-level discrete maths, and half of them would be like, does that mean my graph question is not okay? Obviously, the graph question is fine. If you've never learned discrete maths, great news. You might learn some during an interview. And if you study at university, you might learn some at university. This is great news. A whole sort of maths that you might get to explore. Nobody is going to make you implement Dijkstra's algorithm on a particular graph and watch you do it during an interview. That would be boring. Right, okay, should we actually do some questions? Let's do some questions. I've got a set list so that people can tell me to skip. There's one here that just says mech. Oh, it's the Hill question, isn't it? No one likes the Hill question. If you watched this last year, I know that one of you did because you told me to put the jacket on again. I'm trying not to repeat questions that I talked about last year, but I am going to repeat questions I talked about 2 years ago. So if you've watched the MAT livestream for 3 years, then I'm sorry. Okay. I got estimate 40 and an interview. Did you have technical disruption? Some people had technical disruption. Okay. Oh, you had technical disruption. Won't ask decision maths. That's making me want to put a graph on. I don't know what you're imagining when you say decision maths. I just don't know what you're imagining. It's really tricky to say, no, nobody will ever ask you about that math. That math is banished and not real. So, I don't even know what I'm banishing. Might be some maths I like and feel able to explain during an interview. Okay, my set list looks like this. I'm giving you the set list so that you can plan accordingly and try and skip through further in the video. I mean, not if you're watching live, I suppose. If you're watching the replay, this is my plan of what I've got coming up today. Triangles on parabolas, which is a big favourite of mine. I talk about that question a lot. This question, and then 4. I think 4 is going to have to be change of plan. 4 is going to be trying to show you mechanics, stats, discrete, but trying to show you that you actually like these things. Okay, set list. You did take the second one. You had major disruption and you got about 9 out of 10 on Mat B. Okay, you tell me, how's this interview going to go? Is it going to go like 4 out of 10 and TCS disruption, or is it going to go like 9 out of 10? TCS are not involved in the interview. Right, okay. There's supposed to be an X in here. Let's do a question. I think it's time. Where can we find interview questions? Says this person in chat. Question 301 in half an hour. 10 a minute, 1 every 6 seconds. Where can we find interview questions? Here. Okay, welcome to Matt interview. I'm just checking I've got the right person. I understand your name is Reed's name. I see you had an interview with one of my colleagues this morning, and I'd like to do some maths questions with you, if that's all right. Okay, let's go. So, I'm going to tell you about a sort of function. A function is called increasing, which is maybe something you've seen before, if for all x and y, I need to make sure I'm not writing underneath chat, for all x less than y, f of x is less than f of y. Okay, there's the definition of what an increasing function is. It's sort of increasing for all values that you can put in some sense. I would like to know whether this function is increasing or not. And it's going to depend on the values of a, b, and c. Those are real numbers. Okay, over to you. What does that make you? What do you want to try? At this point in the interview, the person I'm interviewing might have been writing that down. They might have been watching in the Miro boards. They might be scribbling on a bit of paper or something. But it's over to them to have an idea of something to try. And look, we've got a definition. I've never checked whether this is like in further pure maths, increasing for all x. It's kind of not important to me whether it's further pure or not, because the actual maths that you're going to do is, I think, interesting enough that you can do it anyway. For a CS interview, you should expect logic over technique, because the CS degree is like that. They're interested in algorithms and strategies that work. So kind of one step more abstract than algorithm is to have that kind of idea about an approach, which is very mathematical. Brilliant. Okay, so 2 things have happened in chat. Here we go. Maths is happening, and chat has now coalesced nicely around one thing. People are saying did it differentiate in chat, and somebody else has said, are the numbers positive? Good question. Now, this is going to be impossible for me to run, because normally I'm interviewing one person and they would say one of those things or the other, or maybe both in quick succession. And and I would then follow through and talk to them. Okay, differentiation, off you go. Please could you differentiate this function? And spoiler alert, you definitely can differentiate this function, and I don't just mean you possibly can, I mean you will get the right thing. Remember, you got to an interview, you're good at maths, you can differentiate. Create an inverse function. That sounds really difficult, doesn't it? That sounds quite hard. There's a power of 5 in there, so solving those things is pretty tricky. Like you said, either. People have said, are all the coefficients positive? And I say, maybe. Maybe they're all positive. What happens if they're all positive? And it's an important case, and you can tell me. I imagine you've asked that for a reason. It's an important case where you can tell me, differentiate, sub, see where it's positive. Yeah, so someone who's had several ideas. The reason this is impossible is that instead of talking to one person and interviewing them, I am talking to, YouTube tells me, about 130 people. They're trying to interview all of you at once. Oh my goodness, that's quite a few. People in chat are differentiating. It's almost like team effort, except, whoa, look at this. Did I put the CX on there? I did. One person's missed a C, but that's all right. I plan to complete the square. Look at you go. Look at you go. Right, I've got to do some of this on the stream because I've got to get some maths on. So then probably, what colour am I using for the student? Probably like a violet or something. So they probably write something like, aha, dy by the x is 5a x to the 4 plus 3b x squared plus c. And maybe they say this out loud, and I want this to be positive for all x. There's some link between increasing derivatives, which is interesting in itself. We could maybe explore it if we had time. Never had time. Always got something else to talk about. Okay. Okay, and then people are carrying through, and if it even got ideas for what's to do next. Some people stop at this point and get stuck, and that's okay. Getting stuck in an interview is something that happens. If you get stuck at this point, well, stuck as in you stop writing at this point, and you pause and think, maybe this is the point where you say, are A, B, and C all positive? Because maybe you're thinking, x squared is positive, x to the 4 is positive, aha, I want this positive. If A and B and C are all positive numbers, then we're good. And now you've reached the same conclusion that we mentioned before. If they're all positive numbers, you're good. It's an increasing function. And I say maybe or maybe not. And what can we do if they're negative? And that's putting you back in the question. And in chat, yeah, ooh, completing the square. No, it depends if you want to move that A inside like that or not. Some people leave the A outside when they're completing the square. So people in chat are either completing the square or discriminant. Again, 130 of you, even on this, analyze the quadratic. You've split in two. I'm going to go for a substitution, I think, which I'll do in purple because we're pretending that's the student. And they will probably say out loud, sub with x squared. So I want 5a u squared plus 3b u plus c to be bigger than 0. For you, and it would be unusual for a student to write words left and right. Look at that, it's almost a sentence. Students, if there are any students watching, something I really like is when people write any words or say words out loud, because without the words, who knows what's going on. But luckily during an interview, you can ask people what's going on. This is why interviews are different from the maths, right, or different from any test. Or exam. If in the exam you write something ambiguous and the interviewer doesn't know what you mean, but this is done. The test has happened. If you write something ambiguous in an interview, then the interviewer is right there, and they can ask follow-ups. Yeah, we got some conditions coming in chat. Factorize x squared and complete the square. This is great strategy. Someone's asked about physical appearance. A, I look like this. And small talk, B, I have none. Is it possible for tutors to be unconsciously biased by such work? They actually do. So joking aside, the tutors and grad students or whoever's interviewing does unconscious bias training. And as well as that, they are, I think, pretty highly motivated by trying to find people who are good at maths. Like their incentives really are kind of aligned with admitting students with the potential to do well on course. because in a lot of cases they're also the people teaching the people on course, and that's more fun and easier and just better if people are good at maths. So I don't do any small talk in my interviews. I just can't be bothered, and it's possible that a lot of interviewers are not that good at small talk. There's a kind of urban myth or urban legend maybe that Oxford are looking for like the right fit or the right sort of person to fit in with our like Oxford. There's a lot of bunny quotes, right? Because it makes me feel a bit sick. We're nerds. We're just a load of nerds. And if you're good at solving maths problems, that's what I'm looking out for. When we approximately receive for math stuff, it's now feedback happens in January. So now everyone I know working in admissions is 100% busy planning interviews and working on interviews. When it's all over in the new year in January, and that's when we get back to doing feedback. People have got an inequality in chat, which is quite interesting to me. There's actually two things that can happen. So this quadratic on the left, you want it to be positive for all u. People have, I think, correctly spotted that you want to make sure that it has no roots. There's a kind of separate case to worry about where it has no roots because it's always negative. But maybe you thought of that as well. So we want, I think it turns out to be 9b squared minus 20ac to be negative, so there are no roots. And we want c to be positive. Now, if you didn't think of that bit at the end, I can help fix it, right? Because it's not that important, but it makes you think. I can ask, is this necessary or sufficient, right? And I might not use those words, but I can ask, is that exactly what you want? Does that always work? Are we always done? Okay. First you want to put a suit on, now you want to grow a moustache? What is this? Physical appearance? No. As far as I know, St. Catherine's College has not sent out their interview invites yet, but is ready to do it quite soon. Oh, right, okay. Okay. You picked A, right, fine, okay. I think strictly, technically there is a kind of case in here where you there's a case in here where you have exactly one root, which corresponds to a function which has one turning point, perhaps. So I think technically this is like this. Gosh, what do I want? Probably that as well. Not super interesting to me because there's something else interesting about something else interesting to me. Yeah, actually maybe I prefer this A way of thinking about it now that I've seen that in chat. Sorry, it's a happy quadratic. Yeah, you want the happy one. If we want A to be positive, these turn out to be equivalent conditions, I think. Yeah, 9b squared is positive, so you want to make sure the right hand side is. Oh, you want to make sure both of these things are positive. Obviously, the product you're requiring that to be positive because it's bigger than 9b squared, but yeah, okay, fine, okay. I think maybe from the get-go. And sometimes this is good before you jump in with the derivatives. The sort of person who pauses and says, are they all positive? And you say, no, why do you want them to be positive? And they say, well, hang on, if that one's negative, then it's clearly an unhappy quintic or something. That's not a real word, but it's something that comes down. For large values of x, it'd be problematic. For very negative x, this will be extremely negative. Sorry, if a is negative, then for very negative x, this will be very, very large. And for very positive x, this will be very, very negative. So it's not okay. So definitely want, oh, I can't spell. A positive. So not ambiguous over here. Maybe this was clear all the way through, I don't know. Why can't we? Yes, did you hear me say that there's something interesting going on, right? Something interesting going on. National Cambridge are here too. There's something else going on. Let me show you. We've got this rule now, which I think most people have reached, or at least I've seen some people in chats telling me that the thing to check is that 9b squared is less than or equal to 20ac. Modulo and also obviously a is bigger than 0, c is bigger than 0, okay. But let me go back up here and actually look back at the problem and say, hang on a minute. So this is me talking now. Back to blue. I'm not going to stick with this two colour thing. It's too confusing for me. I say something like, what about A equals 1, B equals 10, C equals 1. I put the speech bubble as if the maths is saying that. Obviously in the interview, it's the interviewer saying that. People are always random in chat, and it's okay. It's okay. I've got a set list. We're going to get through it. So I say, what about A equals 1, B equals 10, C equals 1? Because that's an example where it's increasing, I'm sure, because each term is increasing. So they'll each get larger. That is true. I'm not trying to trick you. But it's missing from our algebra down here. It doesn't satisfy our condition because 900 is not less than or equal to 20. It's not. So where's it gone wrong? Where's that gone missing? And this is this is something I like in students that I can also kind of do at interview. Because if you've made this mistake, then you're in the vast majority of people that I've interviewed with this question. I've interviewed some people with this question and they just don't make this mistake, but most of them do. Most of them do get down to that 9b squared 20ac fact, which is kind of partially true. It's sufficient, but it's not necessary. Yeah, people are pointing out possible errors in chat. Why do we have a less than for the discriminant? I wanted the discriminant to be negative so there'd be no solutions for the turning point being 0. So no turning points. So this is kind of the logic, which does kind of work. That if we want no turning points, so no solutions to dy by dx equals 0. So seems to be fine before the substitution. Right, let's put in here. If A equals 1, good idea to check later down lines. A is 1, B is 10, C is 1, all fine, that is positive. And then there's the substitution. And it's going to fail the discriminant. So let's have a quick look at this discriminant down here. Let's look at the quadratic 5u squared plus 30u plus 1. Now that discriminant is extremely positive. This has got roots. You can even kind of solve for the roots. Let's not. Oh, I'm listening to you, sorry. You've got this minus 3b plus root is negative. Yes, okay. You're telling me this better condition. There's this other condition. Yes, I got you. I'm also giving other people time to put something else in chat as well. Some international, very non-contextual candidates snuck into the Word English and Write remote interview workshops. Let me let you in on a little secret about the remote interview workshops for maths and computer science. They are the same as this session. We did the same question that you're doing now. In a smaller setting, without 100 people in the call, but for the same question. How could I have no turning points? So example, x to the 5 plus x is like that. It's got no turning points. And you detect that by trying to work out the gradient and going, aha, the gradient is, 5x to the 4 plus 1, that's positive. There are no solutions to dy by dx equals 0. The thing people are worried about is that it could look like this with some turning points. Turning points would be lethal for this, right? Turning point is coming down on one side or the other. No replies from Royal, yeah. I think you might be the best. Okay. We've forgotten that n is always positive. It's n thing you substituted, or like u or something. Oh yeah, I guess my handwriting is ambiguous, right? Yeah. Yeah. We were only interested in positive roots. Let's put this together. I can see people in chat telling me what to do. The problem isn't whether or not this has got roots for you. And actually this is I've been arguing in slightly bad faith, right? Because the problem's not about whether we have solutions for u. If the function here, this quadratic, which you know and love, if this has got solutions but they're all negative numbers, then we're fine. There are no turning points to the original function. There are values of u where the derivative's 0, but those values of u, if they're negative, don't correspond to real values of x. So, for example, this this quadratic over here has got roots, but they're both negative. And people gave me some different reasons. So now the question is, can we separately spot this case where the quadratic has got some roots, but they're both negative? And there's a trick you can use for that, which we can talk about, I suppose, but it comes down to the idea that if all three coefficients are positive. No, I think that's an example. So I think that's the case we've missed. All the coefficients are positive. Yeah, function was for real values of x. We have accidentally included the case where we looked for complex values of the input corresponding to turning points. It's not really part of the question, right? You can tell they're real numbers, they've got inequalities. Generally things are inequality. Yeah. So we get the condition is A is positive, so AC is the satisfying condition. I saw a person in chat really wanted my attention. They were telling me about this thing, or maybe just the plus root with this thing, 20 AC. And so there are two cases, it turns out. Once you know that A is positive because of obvious big X behavior. And there are two cases. Either the thing inside the square root is negative, in which case no solution's brilliant. Or if it's positive, then you're okay still, provided that the roots you get out here after you've subtracted 3b are negative numbers. And that happens so long as b is positive. So there are two cases then. Either case 1, a positive, b positive, c positive, or case 2, a positive, c positive, b negative, and b squared less than 20 over 9 AC. I think that's true. Yeah, I think that's right. Okay, which is kind of weird. And maybe some of these inequalities should actually be weak inequalities or strict inequalities, so don't mind too much. Yeah, so sorry, the remote interview workshop deadline was really late. For some reason, they were all scheduled for this week, which doesn't work well when the interviews are going out this week, right? So like the St. Catherine's ones haven't gone out yet, and the remote interview workshops have already happened. But luckily, they're the same as this. It's possible one person said they weren't invited, and it's possible that the college removed the bit because they'd already happened. What kind of hints would I give for this question? Very good question to ask here, thank you. So hints along the way. Most people get the idea about differentiation, but I might talk to them about whether they've seen increasing before, or whether they want this function is like quite nice and smooth. So maybe we could talk about, is it downward pointing? We could draw some little pictures. But people normally have the differentiation idea, and then people normally have the quadratic idea. This kind of substitution or like completing the square. If you completed the square, then congratulations, you did a different thing, which I think leads to the same sort of maths. So if you did something like this, then I believe you got something. Oh, I guess I'm going to go under chat again. I believe you got something like this. Let's see how fast I can complete the square. 100, 5, 20. How many A's do I want down here? Just one. I believe you got something like this. And if you want this to be, then the trick is, if you want this to be negative, if you want this to be positive, the big square is definitely positive. Oh gosh, we should probably take A to be positive. And then you want this leftover bit, which is that discriminant we saw before. But there's a trick that might not actually be the minimum. If this square inside here, if 3b over 10a is positive, then great news. This doesn't even get down to 0. So the minimum is actually a little bit bigger. The minimum then is to add back on the 3b over 10a squared and multiply by 5a, which cancels that term out again, and you end up with the minimum c. So it's all quite nice. There are kind of two different cases in here, and a fun exercise might be to sketch some things. I'd also give hints down here about whether to just kind of keep reminding people what they're doing, to keep reminding people why they're looking for turning points or something. Everyone got an interview, but not me. Is there still a chance to get an interview? I'm sorry, but if you've not been invited to an interview, then you've not been invited to an interview. I'm really sorry. There's no sort of backup process of adding extra interview candidates. I'm really sorry. Skim over it quickly. Why did that make you more lost? We're interested in this function, whether it's increasing or not. If you think about it in terms of large x, you can find out that a has to be positive for this to be any chance of being an increasing function, up, not down. If you think about very small x, nobody ever does this, but if you think about very small x, you can convince yourself that c has to be positive as well, because the gradient at x equals 0 is c, which is probably going uphill there. And then for everything else, you can look at the derivative, which is this quadratic of x squared, and then you can try and analyse that. You want that to be positive, I think. So it's secretly a quadratic in x squared, but be careful, there are separate cases, depending on whether this quadratic is just, whether the quadratic is always positive, or whether it's sometimes negative, but only for negative values of u. And that's fine, because negative values of u don't actually match up with real values of x. Really down here we should have said for positive u. That's the trick. We only needed this thing to be positive for positive values of u, which is a different question. It's not quite the discriminant of the quadratic. Completing the square work? Yeah, no, I think I got there. There's a 5 at the front. I know some people move the 5 inside. If a is positive, you could move that inside as well. I think it was David in chat trying to do this, which made me very nervous because, oh my goodness, what do you write here? Is it like this? Oh, I don't even know. 6, 2. And I'm not certain I can get that calculation right. 5a not there, but then no b. Oh, that makes me really nervous. And then plus c minus 9b over 4, 5, 20 a squared. You get the same discriminant at the end. Okay. So it's difficulty ramping in the sense that we did some algebra, and for some people we stopped there. And they've had a respectable interview performance because they've done some algebra, they've demonstrated to me that they can follow this argument about turning points and inequalities, and for some candidates we then talk about why we're not done, and we need to also include the case, or all of them are positive, which beautifully some people intuitively said at the start would probably be important, and it did turn out to be important. For some candidates, I can go a little bit further and put in a little power of 1 here, and then say, what if I change this number to an m? And if there's not very much time, you might just I might just ask for, can you tell me anything at all about what happens if I change that number to an m? There's a 5a in there, it's pretty bad. What would be good? What would a candidate do in this question to be considered good? They would be able to track what's going on at the different levels. Some of the equations that we write down are about the value of the function, some of them are about the derivative, and some of the equations are about this kind of nebulous quadratic in u, which is mathematically helpful but not quite the same thing as the function for the derivative. And strong candidates are able to keep track of which level they're operating, which one of those constructs they're working with, so that they can spot the difference between the second and third things, where the thing with x to the 4 in is actually the derivative, the thing with u squared is sort of the derivative if u is positive for some values of x. Kind of regretting applying for Oxford now. Hoped I could set myself apart with Matt by doing literally months of prep. I hope the prep was useful anyway. That's gone down the drain now, and the offer to interview ratio. See, so the plan was to get an interview and then for that to be one and done. Okay. Could I tell us the nature of M? Not sure. Oh, M. Sorry, it's in my question. What's M? Who? What? Who? Oh, M. So the nature is probably a let's start with like a whole number, greater than 3. Does that help? Yeah, so Thomas has got an interesting, and anonymous down there as well. If m's even, it's pretty bad news. I like that as a way to finish the interview, really. If somebody's done the question and you've got a couple of minutes left, you can explain that you're going to change the powers and then look for this observation that if m's even, it's not interesting. If m's odd, it's kind of interesting, and maybe this is another chance for somebody to tell me about A being positive. You kind of always want A to be positive and M to be odd. And then maybe if I had a lot of time, I would point down here and try and get someone to talk about this small x thing. Never really got people to work on small x in quite the same way. And there's a hard question about the middle power, which I don't think is that important. Do bad on that B. That's a shortlisting question. I think at this point, no further action doing. No further action. Let's see if you're shortlisted. Someone said that was too easy. I have more. This is too easy. Oh my goodness. I learned stuff about candidates by doing this question. And really can make it in an interview setting. People are a bit more nervous. Okay. I've got more. You won't like this one. I think it might be easier. I'm not sure. Okay. Hi to all the people who skipped ahead to the triangles question. It's geometry time. Hi, welcome to the interview. Let me just check I've got the right person. You are Reed's name. Great. I've got a question for you. It's about a parabola. The parabola is y equals x squared, the quadratic equation. I've got 3 points on the parabola, A, B, and C. And B is fixed to be the point 0, 0, but A and C are free to move. A on the left, C on the right. One of the nice things about interviews is that I can say stuff like this, and if I'm not being precise enough or if I'm being confusing, I can write it down more clearly. But you hopefully, A less than 0. I don't have to come up with all the notation. You can invent some of the notation, which is also a fun thing to do. I want triangle ABC to be an equilateral triangle. Where should I put B, A, and C? Okay, this is quite fun. Not all interview invitations have been sent out. I know at least one college is planning to do them either tomorrow or I hope they do them tomorrow. If is odd, you want A0, B0, C0. I'm 200% sure confidence is. Oh, good, okay. Right, quickly read chat. Check I'm making chat happy. There's question. People are telling me about this one. Right angle triangle with a y-axis. You see, my drawing doesn't have any axes on it, so drawing the axes in sounds nice. This is you now. Oh, I can have one more go. You're drawing in the axes, right? There we go. And people sometimes say something vague about symmetry, which I enjoy a lot, because if you say something vague about symmetry on the mat, on an exam or something, well, I can't ask any follow-up questions. But if you say something vague about symmetry in an interview, then I can say, oh, hang on, what sort of symmetry do you mean? Rotation? Glide translations? Or no, reflections, right? Yeah, here, use symmetry to find a line. Oh! You see, people are saying use symmetry to mean multiple things. So it's worth getting the clarification, I think, to find out what sort of symmetry people are thinking of. I think at least one person is thinking about angles. Something I like about this question is that you can think about angles, you can think about heights, coordinates, lengths of lines. Lengths of lines turns out to be a little bit fiddly as a calculation, but you can have a go. Please give the coordinates names. Let's write down some coordinates, right? It's nice to give things names. I'm going to call these A and C using lowercase letters for the coordinates. And I've written their y coordinates in as c squared and a squared because I know that they lie on the parabola. So I'm not calling them, I don't know, this is just me I suppose, but I'm not calling it x and y, subscript c, and then writing down an equation that says yc is equal to xc squared, because it's too much writing. Easy trig question. You want root 3? Basic triangle. Yep. Okay. People want to speed up. So some people are doing the 60-degree angle. It's good having about 100 people now. 30 people didn't like the polynomial. Some people are doing angles. Some people are doing lengths. People working on lengths have hopefully spotted the symmetry thing, because the lengths approach is really messy if you have arbitrary positions for the corners. There's just too many variables. So that's the point where the interviewer might join in and say, hang on, lots of variables here. Can you tell me anything about Reed's page, XC and XA, or whatever you've called them? Here, can you tell me anything about A and C? And presumably somebody might say, aha, A is supposed to be equal to minus C by symmetry or something, which is good because then we can have a chat about symmetry. The people thinking about lengths might say, well, these sides are the same length, so they reach up the same distance on the parabola. Somebody might say triangles are symmetric, and I'll say, how do you know this triangle is symmetric? Right. It's true that equilateral triangles have a line of symmetry, and so does the XY plane. That doesn't mean they have to line up. I could put a square on Cartesian coordinates without lining up the sides, right? It's not always true that symmetric things are always aligned with each other. It would be nice, but it's not true. But that's not what you were thinking, of course. You were thinking something cleverer, and now it's your chance to say it again, or say it better. Oh, you did lengths, so you can just go for it. But maybe you did lengths with only a couple of variables. So I had some A's and C's on the board. What I don't like is, it's not good practice for me, I think, to let people go A, B, C, D, and then start doing like C squared plus D squared, A squared plus B squared, write down the easy ones, and then write down the really tricky one, which is like C minus A squared plus D minus B squared. Actually, I've seen people, I reckon it will take too long. I'm going places with this question. This is part 1 of 4, 3, 5? Anyway, I don't normally say it that way. It's A root 3. Brilliant, cool. Easy peasy. With angles, but with angles you've also got to convince me that it's symmetric, right? You got this kind of thing. Oh, the thing is, it's balancing on its point perfectly. Oh, okay. Why not? I suppose. Why not? And part 2, I suppose. I'm now saying part 2, which is not what I do during an interview. I'm going to stop doing that because it's not authentic. What other triangles can you make? I quite like an open-ended question. Especially if the open-ended question leads up to something quite specific that I'm about to ask, because it might just help you have some sort of ideas or thinking time to build up some intuition with the problem. You only met this problem just a minute ago. Maybe you've done some algebra. Yeah, you're all correct, by the way. It's something to do with square root of 3. You can do this without considering the side lengths, which is kind of nice. Equilateral triangles are just gorgeous. As well as having 3 sides the same, they've got 3 angles the same, and they've got just 3 of everything, right? They've got these like symmetries. There's some relationship between their height and the base that people have talked about, reading the base across the side. There's a root 3 over 2 apparently, like brilliant stuff. Equilateral triangle is just classic. I think, now that I've put the coordinates on, I said out loud at some point A is on the left. I said out loud C is on the right, but I'm out. As soon as we've got some coordinates. On the board we've got my choice of the coordinates. You might have chosen different letters, in which case please interpret this as you see fit. I'm tidying up a tiny bit. There we go. A on the left, C on the right. What other triangles can we make? Miles has gone for the big guess of any triangle, which obviously gets a follow up like, okay then, here's a triangle, let's make it. A and C are fixed, they're both on the curve, otherwise anything goes, right? What's the curve got to do with anything if they're off the curve? But they're on the curve, but they can move around. So C could be somewhere up here if you want to make a, I don't know what sort of triangle that is. A could be somewhere way up here. Tough questions? Yeah, we're getting there. What other triangles can you make? Sometimes people tell me about, people are going for the bigger guess at the moment, which is also, I think, scaring off other people from making smaller guesses. That you can't make right angle triangles apart from when they're 90 degrees. Right, okay. Let's try and make a triangle. Okay, so new diagram. Maybe you've told me about some triangles you plan to make. Here's what I would like. I would like triangle ABC to be similar to the 3, 4, 5 triangle. And this is a good chance for me to check if you don't know the word similar, and to check that you know what similar means. You know, not literally 3, 4, 5, but a scale of this triangle. If you put A, B, and C all very close together, then the angle B would be close to 180 degrees. That's true. I think slightly less, right? So you can make a triangle with a very large angle. Yeah, scale using similarity. You see, the word similar has now entered the question. Can't make degenerate triangles. It was a good note. Yeah, I like that. Now chat's going to argue about whether degenerate triangles are triangles or not. Don't get them started on 0 being a number. Cool. Just realised we've gone a little bit past 6, which means we've been live for at least an hour. If you've been looking at the screen for the last hour, don't forget to look away from screens for a little bit. Maybe look at some maths. I'm going to drink some water. You might like to do the same. Today's stream is sponsored by water. It's one of the things that you're made of. What's the smallest angle on B? Yeah, okay. So putting A and C really close to B makes the angle large. Could we make the angle really small? Not obvious. Oh no, here we go. I slightly encouraged that. Okay. Oh, guinea pig break. If your email didn't say how many interviews, please wait until they've told you the times and dates of interviews. If they're planning to give you 2 interviews, they'll tell you the times and dates. Complex numbers. Don't start chat on complex numbers. Okay. Have we got any takers for my 3, 4, 5 triangle then? So I was going to post solutions to the second mat, and then 2 things happened. 1, really ran out of time. It became a bit too late to be helpful. 2, we decided not to post it. I'm really sorry. I know we did a vote where we wanted it, or you wanted it. There was a poll in chat. Unfortunately, I'm not doing it until perhaps in the new year. I know that's sad. The framework now is that it's closer to feedback because of the multiple choice nature. Lots of people asking about Oriel in chat, which makes me think that Oriel have not sent them out yet. Circles. I like circles. I wish people would just say circles to me in chat, because circles. I wish people would just say circles. Oh yeah, B is still fixed at the origin. Circles in an interview, because I can say, well, what circle are you thinking of? I mean, maybe you're thinking about the one with the right angle over here. You're very interested in Thales' theorem. Okay. I think there's multiple solutions. I'm not certain, but I think there's multiple solutions. The ones that I think work best is to put the right angle at B. Sometimes, I don't know why, but people often opt to put the right angle at B. And then usually people start telling me about side lengths, which gives me a chance to intervene. Because this time the coordinates are all mad. They're quite horrible expressions, involving like A and A squared over here and C squared. But the expressions for the lengths, especially that long one down that side, it feels longer, doesn't it? It feels like it's longer than the other 2 sides. It feels like a hypotenuse. Anyway, the expression for that is pretty horrible. And worse, you want it to be like 5/3 of some other expression. It's pretty nasty. So usually at this point there's a Thales fan in chat, which is very fun to me. Yep, bring in a variable if you like, and we've got all the circles. Wait, what is this circle? Is the circle good? Does the circle get you somewhere? Now I'm starting to think. I'm using circles. Why are C and A swaps? Oh, I'm an idiot. Which way around were they before? Oh, A on the left. I guess that makes more sense. It's just general idiot James, not clever idiot James, just normal idiot James. I just got here is there a dress code? There was a message briefly in chat. Okay. Right now variables, dot products and ratios. Good luck with calculus 2 and calculus 3, whatever those are. People in chat, big fan of circles now. This question? In this weather? It's more likely than you'd think to help, but not obvious to me where the circle. Do I even know where the centre is for the circumcircle of this? Is chat suddenly really into circumcircles? Oh wow, okay. I've seen multiple ideas. The length of lines is interesting to write down, but I just want to highlight how kind of difficult this is. The difference of the squares is that one plus c minus a squared, which kind of is tempting a little bit. It factorizes a tiny bit. You can bring out a c minus a because there's a difference of two squares here. It's still not very nice. A bit nice, but not that nice. You get kind of a horrible leftover term inside. And what's worse is you want this to be sort of 5/3 as long as, I don't know, whichever one's short, c squared plus c to the 4 or something for the length of this side. That equation is just nasty. So instead, there's this idea about lines being at right angles. To say that the gradient of this line is c, the gradient of this line is a, and these things are at right angles. So AC should be -1. I mean, that's much nicer, because the equilateral triangle question became easier when we decided that A plus C was 0. The equilateral triangle question became easier when we decided that A plus C was 0, and this question gets a lot easier when you've decided that A times C is -1. You got a quartic in A squared. Oh, it sounds like you multiplied some things and squared some things. Ugh, nasty. The solution is actually quite nice at the end. Let me try and do the algebra for you. Once you've had this kind of idea, or if you've simplified this quite a lot, then the algebra is a tiny bit messy, but actually maybe a good exercise in square roots and stuff. Sometimes it's just nice to let people get down to a solution, you know. So you want this side over here perhaps to be 3/4 as long as that side over there. I'm assuming you've written down some expressions for side lengths. And you've just decided that AC is -1, so I suppose that means that C squared is equal to 1 over A squared. I mean, then this is quite nice because this is 1 over A squared plus 1 over A4 square rooted is 3 over 4 A squared plus A to the 4. And I think something rather beautiful happens on the left. Can I get this right? Yes, please. 1 over A squared, I think, bringing out a square root. Gosh, it'll be really embarrassing if I get this wrong. Yeah, there we go. And you can bring out an A over here. Is A positive? Oh, don't tell me A is the -1. Not an intended trap. And then they cancel a little bit. And you get something like A cubed is, or minus A cubed possibly is 4 over 3 or something. That's just quite nice. So it's like, oh, minus 4 over 3 to the 1 over 3. And C is -1 over that. 3 over 4 to the 1 over 3. Which is kind of quite nice. Fraction to the power of a fraction. I think, might have messed up. Yeah, y equals mx and y is -x over m. And you know they intersect the parabola, so you can find the coordinates. The right angle could be at A or C. There are other cases, but this is one of them. So well trained from the previous question to spot other solutions. There are other solutions, but this is enough for me to know that I can make the 3-4-5 triangle, or something similar to the 3-4-5 triangle, which kind of answers the question a tiny bit. What other triangles can you make? So to wrap things up, I might go back to that question and say, what other triangles can you make? And then you might say, aha, I'm now pretty confident that I can make something similar to any right angle triangle. And that's very close to being done. There is an argument to essentially the only remaining step, if you want to make all triangles, is to consider fixing the angle at B. Make a similar copy of any triangle similar to any given triangle, is to fix the angle at B and wave it scan it from left to right, like you're a searchlight looking out to find these kind of intersection points on the other side, and to scan the searchlight left and right. On the one side, one of the sides ends up being much longer than the other. On the other side, it's the other way around. In between, you can make everything. I think if the candidate didn't spot the gradients idea, then they've got some equations like this. They still have this rather nice looking equation. This is rather nice, and in fact, you can make this work. I think you can do something with this. Which is something like, oh gosh, what can you do? You can square both sides, and that gives you information about c squared times c squared plus 1. And I think that's the sort of thing you wanted over here. So then you sort of plug it back in, rearrange the other equation, and you get some sort of hideous polynomial at some point. It's a lot of mess, and when I've done it with people, you should try to see this. What do we do if we get asked a question we've seen before? For example, you've been watching the MAT Livestream for 3 years, and you saw me do this question back in 2021 on the livestream. You should probably say that you've seen it before. It's the honourable thing to do. I believe you sign a code of honour. Interviewers are, I think, better at spotting that someone's knows what to do. Better at spotting it than you think. Actually, in an interview, it's quite hard to. Yeah. If your concern is that lots of other people have seen the questions before, then good news. The questions that I've seen people use are not guessable in a sense. People seen my question before? This new? I wrote this for an interview. At the time I wrote this question, I was not aware of anybody else trying to find similar copies of triangles on a parabola. That's not maths research really, because who cares? But writing a good interview question occasionally involves trying to come up with some maths that's appropriate to ask about and vaguely interesting, and also not every sixth former has seen before. It's not dissimilar to trying to make an interesting Oxford Online Maths Club episode. Right, okay. Really concerned on Miro because my writing looks terrible, and I think it'll affect how I work. Don't work on Miro. If it's slowing you down, or if you think it looks rubbish, I would say try and get the interview switched to a backup option. There is some advice on using Miro on the Oxford website in the interview section. And if possible, you might be able to borrow some device from your school or college. But we know that, gosh, if nothing else, we know from marking the mat that some people's handwriting is worse than others, and yet might still be great at solving maths questions. I also know this from my current students. If they're still watching, hoping that I do shout outs for the rest of them, then work on your handwriting. Okay. If you don't say that your working will not be as genuine as you're doing a new question, can you show your skills for filling out a question? Yeah, okay, good talking about this. Look, this is your questions. What is that? My questions on the website. System files. Oh, where did I put these up? It's an interview question I used in December 2018. Here it is. Here it is. Yeah, they're right. This is on the website. Are there more in here? Method 2. Ah, maybe there's what, second part. When did I put this up? This is great. There it is. When did I use this? Gosh, 2019. I've been talking about this question for 3.5 years. Thanks for that. When did I type that? Good. Do we need 2 monitors? Hopefully not. Don't buy a second monitor. I've done interviews where someone could get into Miro, and that was more helpful than being able to see them in Teams. So we kept the Teams call open so we could talk to each other, but hopped into the Miro board. I wouldn't do 2 monitors. If I have a copy of the MAT on my laptop, would it be okay to share it at this point of time? I don't think I've got any mechanism to stop you. Am I supposed to be on the web? Oh gosh. Yeah, no, okay. What are the other parts of this question? Yeah. So I kind of skipped this discussion about making other triangles. I kind of just told you the answer. And this bit in the middle about what are the triangles is similar. This idea about making things. I also skipped to tell you about being similar. So lots of points where we could have had an organic discussion, except there's way more than one of you, and this organic discussion is a little bit complicated. Teams on phone, Mara on the laptop would be fine with my college, fine with me. Yeah, okay. Good, okay. Should we do some more? Let's do some more. So, geometry question. So, I've been interested in something called a partial eclipse, where viewed in 2D, you have one circle, which is the sun, and you have another circle, which is like a moon or a planet or a spaceship or something, that's moving past the sun. And this is all in 2D, because from our point of view, these things are just moving past each other and they're circles. Okay, the thing that physicists do is to look at the light that we're getting from the sun. So we're getting, to start off with, all of the light from this circle. We can see all of the circle, but during the eclipse, some of it's being blocked by the moon or spaceship or planets or whatever's going past. I would like you to draw me a graph of how much light we can see over time. So if you're playing along at home, please draw yourself some little axes, and hopefully I've given enough description of this problem. Is this physics? I don't really know. Is it mechanics? I don't really know. There's no dress code for interviews. Wear something comfortable. Prepare some maths. Hey, look! There's the ladder question. I love the ladder question. It's a bit of a classic. You can't actually use it for interviews because everyone knows it. Well, not everyone, but. Do you find that interviews tend to be quite similar? Not really. I mean, people take questions in different directions. People have slightly different approaches and maybe get stuck or maybe get through different amounts of questions. I'm not sure I've done a great example of what that's like. I do tend to repeat questions between people. Obviously, if you're worried about cheating there is no incentive to making sure that other people have a good interview experience and get the right answers is something nobody wants to do after their interview. I do repeat questions so I can compare people. Yeah, not between years though. Context of the question. Oh yeah, sorry. So here's the sun. The sun is a large circle. I'm not a scientist. And this small planet here is going to move. Oh, can I make it move? I think I can make it move. This small planet is going to move in front of the sun. So while it's moving there, and move across at constant speed. While it's blocking the sun for a bit, we get less light from the sun. It's a sunny day, it's a sunny day, it's a less sunny day, it's a less sunny day, it's a sunny day, it's a sunny day. I'm looking for a graph of how much light we're getting over time. And I've given the game away a little bit by saying sunny day, less sunny day, sunny day. I'm wearing a hoodie, it's fine. I mean, there's some probability that I'm going to be wearing a hoodie. And the ladder question, by the way, so sub question for people who want the ladder question. You have a ladder like this. So you have a wall and the floor, and a ladder, where the middle of the ladder is painted pink or something, and the ladder, it's not really mechanics, but the ladder falls over so that this point of the ladder slides down the wall, and that point of the ladder slides out. The feet of the ladder go out, and the top of the ladder goes down. The question is, what happens to the pink point? Where does it go? It sounds like an open-ended question. It's actually a calculation. There's some geometry in there to work out as it's going down. It's not about velocities and gravitational potential energy and friction. It's none of that. That's used in the phrasing of the question, but none of that's actually important. The thing is that the ladder's got a fixed length, and it's constrained to move like that. You can't do it with your hand, right? Whoop, 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 whoop. And then there's some curve like that, maybe. Or maybe it's like that. I don't know. Max curve decreasing, straight horizontal line, curve increasing. Aha, good. Previous live stream, yeah, with the sun. I tend to talk about the same questions a lot. I'm surprised that's the first time someone said that I've seen. I mean, somebody linked me to a PDF of the same question, didn't they? So that counts too. Increasing functions? I guess I used that at a remote interview workshop earlier this week. Shut up, James, and draw the graph. Down, across, up. There we go. Cool. And that's actually the picture that you see in A-level physics textbooks, if you read A-level physics textbooks. I'm interested in this corner here, and where it just starts decreasing. I guess that's where the planet has just started to overlap the sun. And I'd like to show you an approximation that you can use to analyse what that's like. The idea is to zoom in really far. So just as the planet has started to cover the sun, the idea is to zoom in so far that from some point of view, maybe I've rotated the camera as well, from some point of view, the sun looks like a parabola. It's got some curvature to it, but the sun looks like a kind of parabola. Y equals ax squared. And this planet that's going past, you've also zoomed in so much that that looks like a parabola. Y equals t for time minus bx squared. So as t changes, this is going to move up and cover up the sun. So sort of none and then some. And I guess the trick that I'm telling you is that more or less you can approximate these things with parabolas. And in the interview you might have a discussion about why that is or which parabolas, but the thing I really want to know is what happens with this approximation to replace everything with parabolas. What happens? There's a calculation to do that. Is it the envelope? I'm never sure. The envelope is something like all of the points that any point on the ladder moves through, and the middle is something different. I think the answer to the ladder problem is something like the envelope of points is some parabola sort of thing, and the midpoints move along a quarter circle in the opposite kind of curvature, which is really weird to me, but never mind. It's kind of a good question, a bit of a classic. Why is the sun curving more than the planet? You're right, I'm an idiot. Well, not an idiot, I've just drawn a weird picture. I guess you've got some idea that the curvature here, or the coefficient, might be related somehow to the radius of the circle. And there is a relationship. It's called the radius of curvature for what that matters, but that doesn't matter. Good for time? 20 minutes. Bit of mechanics. Do I know anything about Balliol status? I'm afraid I don't. I don't know. I imagine if they haven't sent it out yet, they'll send it out tomorrow. I saw someone asking about international interview times. Please don't assume, but colleges do try to give you plenty of notice. You are not meant to know that circles approximate to quadratics. That is something that I'm telling you. I'm instructing you to approximate this problem with this pair of random parabolas. If we've got time, I might talk about why that works, or get you to talk about why that's a good idea. Why have I got a t here? Why have I not got a t in any of the other ones? There's nothing else changing with time. What am I asking you to do with tangents and parabolas? Okay, so this one represents the planet or moon or whatever that's moving past the sun. As t changes, it's going to overlap. That's very interesting to me because the amount of overlap is something to do with this thing you just sketched up here, to do with how it starts to lose light from the sun. It's on you to tell me what the connection is, I suppose, or what the relevance is. But there's something like in terms of A and B. Let's just do this kind of sub-problem, right? I claim this is relevant somehow. Sub-problem in terms of A and B, maybe. As time changes, how's the amount of overlap change? I suppose that's what a hint is like. You can do some integration varying the value of t. That sounds very sensible. You'll have to do some maths along the way, of course, to work out what you're integrating, what sort of thing it is. And I have this in the category of like reasonably tough math question. Is to do that integral with the parameter t in there. I think we've done similar looking math questions. Gosh, that's a poorly drawn parabola. Look at that. Look how bad that bit looks. It's rubbish. Can we integrate? Yeah. Please do. Parabolas. Yeah, I reckon you can integrate. You can set t equals 0 because that's where stuff starts. I agree. Yeah, there was no overlap at that point. And then when t is positive, some overlap. We start to lose some of the sun. The point of tangency happens when t is 0, when they both go through the origin. Sorry, I wasn't trying to trick you with tangents. Did I say tangents? Maybe I think I said the point of tangency, right? I tried to set it up so that would be t equals 0. Okay, right, never mind. Good. Why can we approximate a quadratic? Good question. Good question. Fact that I'm not going to prove now during your interview, if this is an interview, you can approximate any curved line with a quadratic nearby. So this is not going to give us the entire picture up there, but it's going to be a valid approximation for just like time just after it started to cover up the sun. You can approximate anything with parabolas, they're really good. It's a Taylor expansion, which I think is not something people learned. So the point of this question is not to check whether people learned about Taylor expansions. I don't need to know anything about Taylor expansions in order to get through the question, so much as you can approximate things with parabolas and it's all fine. Yeah, there's Taylor series. Would it be easier to integrate with respect to do y? I have no idea. That's up to you, I think. I can see advantages and disadvantages. You're going to probably want 2 parts to it, right? 2 parts to it if you go with respect to y, because you want to change what the function is when you get to here. So you're going to need to work out where here is. You're going to need to work out where that is, and where that is, I think it's just the opposite, isn't it? The other side. You're going to need to work out where those points are. So yeah, it might be just as hard, because if once you've worked out where those points are, integrating with respect to x is looking pretty tempting. Yeah, people have worked out that it was St. Catherine's that I found earlier, and now people are making noises about Balliol and Oriel, so you know. Oh yeah, that's a banger as well. These are on our website somewhere, possibly the same page with my 2019 interview question that you just saw. How many ways are there to cover a 2-by? No, I think it's Fibonacci. Is this Kepler's? No, I don't think Kepler's involved. Good question. I don't think Kepler's got a look in. This kind of parabolic approximation is something that I'm quite interested in. Anyway, I'm not sure if anybody's actually doing this integration. Oh yeah, somebody is. There are roots. There's something to do with root t over a plus b. There's loads of limits. Brilliant stuff. Did that say Lincoln told you Monday morning? That's almost a selling point. That's almost like, apply to Lincoln. We will send you decisions astonishingly quickly. Yeah. Okay. Okay. So there's some maths you can do to work out this area. It turns out that you get some sort of really complicated area, complicated stuff with fractions in and powers and stuff, times some function of time, and there's some t in here, some dependence on time, which is what I really care about, because the numbers a and b are something to do with how large the sun is, and people already dunked on me in chat for making a smaller in magnitude than b, or larger, whichever one it's not supposed to be. There's a great big cube root or something like that, right? Is it t or is it t to the 3 over 2? Let me just think quickly. Should probably have written this down before I went live. I believe it might be t to the 3 over 2, you know? Let's get a second opinion from chat. Let's get a third opinion from chat. Thank you. Let's get a fourth opinion from chat. It's third of t is like roots, right? Every single final decision be sent out on 9th of January, exactly. Or will it be more wishy-washy like interview invites? Less wishy-washy. Don't love the phrase. Because what's going on now is colleges are either scheduling and then emailing, or emailing then scheduling, whereas by the by decision day, we're all done. So there's no reason to slow that down. A t to the 3 over 2. Okay, I'm taking t to the 3 over 2. I'm really sorry for the person who said t to the 1/3. You just say t to the 1/3 very quickly, and if I could see you're working out, again, either in a Miro board or on a bit of paper that you hold up to the webcam, I would be able to help you fix that. But it's t to the 3 over 2. Then the hard bit of the question, it seems, for some people, is what's that like? What does that look like? And t to the 3 over 2 is not a normal one to sketch. You're used to sketching t squared or t to the 5 or something. T to the 3 over 2, I guess 4t bigger than 0. And there might be a minus sign out the front or inside this cloud somewhere. Looks almost more like a kind of animal to me, maybe a little dinosaur. The important thing is that I'm having a good time. We do some interview questions, but also I'm having a good time. We're not doing eggs again. Eggs was 2 weeks ago. Last time we met, I talked about eggs way too much. Now I'm drawing dinosaurs. What am I doing? I'm giving you a chance to draw t to the 3 over 2, I think. Hello, somebody's just joined with a question that's going to appear in chat. Now, here it comes. Just about to join. If you apply to Imperial or Warwick but not Oxford, will we still be sent our MAT scores? Not by Oxford. You can request your MAT scores from Imperial or Warwick though. At the end of their process, they have an admissions feedback process, which I believe happens in about March. And as part of your application to Imperial or Warwick, you can get your admissions feedback from them. But I'm afraid you can't get admissions feedback from Oxford if you haven't applied to Oxford. The test is part of the admissions process. That's the thing. Yeah, hi, I left. Is it convex curve only defined for x positive? Yeah, something like that. Yeah. I like that. No derivative and then up. And then the point of doing this is that we can go back to our picture, which people maybe drew with straight lines and sharp corners, and we can say, so what does that tell you about the corner, right? Linking it all together. We've seen that as curved shapes overlap, and I'm telling you, it doesn't matter what A and B are. So it doesn't matter how curved they are, it doesn't matter what the values of A and B are, you always get this t to the 3 over 2. You always get a graph like this. You always get something like this, which has zero derivative and then changes value faster and faster. Which means that the corners of this picture, and I would let you maybe redraw this, the corners of this picture should be smooth in some sense. There should be zero gradient just to the right. Just as the moon starts covering the sun, there should be the gradient should match up. So no sharp corner, a smooth thing. And that means that people who drew kind of sigmoid shapes are kind of about right in terms of the derivative matching up. Then hard question involving geometry, which I know people don't always love to do. I've set this question for other things, for other reasons. Okay, the circle is like halfway over. Please use trigonometry and angles and stuff to work out what's going on. What the area is. Imperial maybe haven't done their offers yet. They are maybe waiting for MAT scores. good. What does a good interview look like? Most people do get hints, to be honest. Even really strong candidates, because the questions are a bit weird. What if you already drew curved edges? Well, we're explaining why that's correct. I might say, if you drew a sigmoid to start off with, I might say, can you explain why it's like that? And then we're gonna do, one way or another, we're probably going to do this calculation together anyway, because I've got this idea about approximating curved surfaces with parabolas. Hard extension, or things that you could talk about afterwards, are sort of like, are you sure about all four other corners? All three other corners, they all like that? Which way round are they? There's some subtleties with minus signs that aren't very exciting to me. Or maybe what happens if you stick a translation on this, so that as well as moving to cover up the sun, it's also moving sideways, which is a kind of accurate representation of how this has some normal velocity into the sun and also some velocity in a different direction, I guess tangential velocity. Because really it's moving this way, so it's got normal and tangential components at the moment of impact. Sorry, not impact, covering up. Aperiodic monotiles, brilliant. There's some good new ones this year. That's probably, well, I don't know you, but that's maybe what you've seen. We've got some out the front of the maths building, Penrose tiles. Oh no, you've said monotiles. You're not interested in my Penrose tiles. You don't want that. You would like monotiles. It's a bit annoying. It means I need to remake this animation, right? So I have this animation that plays sometimes on the stream like this, which is made of Penrose tiles, and since I made it, people have discovered some even better tiles. Intuitive feeling, yeah, cool. Which we're then going to back up with mathematics. Cool, yeah, it doesn't. If somebody drew a sigmoid, kind of sigmoid shape, I think there's probability 0 that they've got this argument in mind. So I'm not gonna try and get that out of them. Stick to my plan. Anyway, I think this calculation is kind of neat. I like the way you can kind of ignore a lot of coefficients and just talk about 2 to the 3 over 2 being the interesting thing for your picture. It's got some ideas about limits and limiting behaviour that is not in A-level maths, but is interesting anyway. I want to quickly describe a mechanics question because I saw people earlier on who were a bit scared of that sort of thing. Question works like this. You've got a hill and a particle that's going to slide down the hill. This is a problem that you've seen in A-level mechanics class, I'm sure. The particle starts with I guess this is x equals 0, and it has no velocity to start with. But it's on a hill. The hill's got some gradient, and it's going to slide down the hill. So you know what's going to happen. It's going to get faster as it goes down the hill, and it's sliding down this hill. Now, you do this at school with a kind of straight hill, and you add all sorts of friction and air resistance and stuff. And I don't care about friction or air resistance today. I'm just interested in what happens as a particle slides down a hill with a shape y equals minus e to the x, the kind of exponential slide. It gets steeper and steeper on the way down. I'm interested in how fast the particle's going. And then you can ask me a question about, we can do some follow-up thing. Somebody's asked me about downloading Miro. I don't know if it's possible to download Miro. I think it's a browser-based thing. I'm going to look a bit silly if it's possible to download it, because I've been running it in browser for about 4 years. I sort of almost hope it's not possible. Can we be asked further math questions if we've learnt it in school? Because the interviewers are there to help and have got a plan of how to hint and how to help people through questions, we can ask questions. This is, for example, not a further math question, but I can ask it to, I think, anyone, because I can prompt you to talk about the kinetic energy. So we have this idea about kinetic energy and gravitational potential energy, and if not, then we can learn those together. For example, the gravitational potential energy might be something like mgh. Well, what's h? I guess it's the value of y. Maybe. Is that how height works? Yeah, that's how height works. I mean, initially it's got no height. Initially it's got height 1 and no velocity. So I think probably half mv squared plus mg1 minus 1. I might have got this mixed up. I'm trying to go in a bit of a hurry. might be constant or might be 0. So as it goes down, this thing gets more and more negative, so that thing has to get more positive to compensate, so it can be faster. And then the slightly hard part is to translate, okay, now it's over here and it's got some velocity. Whee! Or what we've actually calculated here is not velocity, we've calculated speed, which is the magnitude of velocity. What can you tell me about this direction? The direction is, of course, it's going down the hill. It's tangent to the hill. So now we've got an algebra question or a calculus question, I suppose. Please could you find me the tangent that it's moving on? Just disconnected again. That wouldn't have happened if I downloaded it. Good, and it's going to keep going. It's going to get faster and faster. So there's some stuff to do here. There's some sort of maths, but it's not extremely mechanics themed. Well, I like doing this because people are often aware of these concepts and you can write them down, and then it turns into this kind of more familiar maths question where you've got maybe hiding in here somewhere there might be a differential equation or something. You can try and find it. Think about components of weight, which is something to do with gradient. Components of weight. Oh yeah, yeah, you can, I suppose. The tangential component is pretty scary to think about because the tangential component on your A-level problems, the tangential component is always in the same direction. Over here, the tangential component changes because the tangent changes. Or maybe it could stay the same even if the velocity is changing direction. You could. I'd probably try to stop you, I think, because I think it's complicated. I want a gap here. Can I be asked anything? I'm probably going to ask you the same questions that I asked other people for comparison. Maybe this is the right way to answer this question, is we do not try to ask you what you are currently studying in school. Maybe that's the best way to answer it. We are not trying to set you the same test that you got last Friday at the end of the week in school. We are not trying to do your A-level exam early. We are not trying to do that. Instead, we're trying to give you a problem you haven't seen. And that might involve, I don't know, particles sliding down curved hills. It might involve weird approximations where the area integral from something involving the square root of t on both sides and something involving some height involving t might turn out to be t to the 3 over 2, interpreting that fact but not the coefficient in terms of a graph. It might involve weird similar triangles found on a parabola, or it might involve these kind of parabolas that mean one thing but not another, and trying to work out what the relationship to the derivative is and doing two things at once. It can involve all sorts of stuff, even graph theory. There's a maths question I like quite a lot, which is to say you've got 4 towns connected by roads, and each road is closed. Each road is closed with probability 1/2, or maybe just probability p. Each road is closed with probability 1/2, independent of the others. What's the probability? What's the probability that you can get from any town to any other town, maybe going via towns, that the network is still connected, if you like, that you can still get from A to B. Even if this is roads closed, you might be able to go via C, or maybe if you have to, via like D and then C and then B. That might be the case if all of these roads happen to be closed, but these ones are still open. Or hey, I can go the long way around. But if those 4 roads closed, then it's not okay because C is cut off. This is an old STEP question actually, but if I used it in an interview, can't remember. I can't remember where I saw this question, but it feels like an interview question to me. How do we do the particle question? Weight component tangent to the slope. I'd stop someone from doing it because maybe it's okay. I got really nervous because you're working out the acceleration, but well, maybe this is fine. You're working out the acceleration in the tangential direction. You also need to keep track of how the tangential direction is changing as the particle moves. If that's your plan to work out a differential equation, then if you want to kind of know raw at the base of where is the particle, then you might need to keep track of something like x. So you might need to allow for the fact that the tangential acceleration is massive, but because the hill is so steep, massive tangential acceleration doesn't correspond to x acceleration at all. The kind of steepness to the hill comes into both parts of that, which makes it maybe less like the A-level question that you want it to be. Oh, you're going to use on a separate touchscreen device. Okay, if you've got a separate touchscreen device, go for it. Do people reapplying on gap years have an easier time of interview just due to being more experienced? I mean, maybe. I don't think I'd describe the interviews as an easy time for anyone, really, because of the ramping nature of the question. Bear in mind that people on gap years are more experienced in terms of A-level maths, but it's not quite what we're testing, and they might be less recently experienced. So people on gap years might have had time to forget some maths as well. It's not obvious to me which one of those effects wins in general, and for individuals it depends on the individual. So people on gap years who are watching, maybe revise some A-level maths, but don't rely on that being enough for exactly what's going to happen in an interview. Yeah, okay. In some sense, comparing people against other people is always very difficult, isn't it? Sorry, for other subjects, Miles is reminding me that other subjects exist, which is where we pull out back to the most zoomed out zoom view. Just pull out. What have we made? Axolotl shape. It's like a neuron. Oh, amazing. Other subjects exist. Maths and computer science students, you might have separate interviews, or you might have a joint interview that does kind of bits of both. Maths and philosophy interviews, you might have a maths interview that's very, very mathy and does maybe some of the stuff that I've been talking about, and maybe a separate philosophy interview that talks about your interest in philosophy, maybe talks about a particular philosophical problem they want to look into. The sample question that I've seen for maths and philosophy is, what does it mean to blame someone? Or what does it mean to blame? And there's lots of things to say about that. So I guess I want to finish by saying there are other sources of questions out there. For philosophy in particular, it's a little bit nebulous. I'm not sure I know very many example philosophy questions, but there's some on the Oxford website. For maths and computer science, there's some on the Oxford website, and there's also a lovely blog by one of my colleagues, whose name is Varun Kanade, Varen Kanade, who has put some interview questions on their blog. So if you want to see some maths and computer science interview questions, there are now 6 of them, which is more than I was going to say. This one's definitely, I mean, this is about the Riemann zeta function, which I think is not on further maths, but it's a good example that you can do stuff with the Riemann zeta function, even if you haven't seen it before. Good. Do maths and computer science people, to be really clear again, I am not going to promise any particular topic for any particular student. Are international students and home students treated the same? Yeah, I mean, treated fairly. Looking for the best maths students for our course. Yeah, philosophy questions philosophy and questions just go together so well. Of questions. When will U1, U2, Mu1, Mu2, Mu3 come up from MAT23? I normally post those at the end of the cycle, so in January. Is 65 for 70 good for maths and philosophy? In some sense, if you're a current applicant, then you don't care really, because you've either been shortlisted or you haven't. If you're a future applicant, please give me until January, and I'll post the numbers in January. Can I promise no eggs? Yeah, sure. I will not ask my egg question. Will you get statistics questions? I am not going to promise that you won't. But I hope that I've convinced you that if you get a stats question, it will not be how do you calculate the normal bivariance of a Poisson distribution. The amount of assumed knowledge is maybe less than you think. Knowledge is fine. Understanding is important, and the ability to learn new things and to adapt to unfamiliar things is really important. Good. Okay. So I think I'm not going to tell you, because I think it would just stress you out. If it's a small number, then it'll stress you. If it's a large number, it'll stress you. We're doing significantly more work than normal. Maybe you might get separate philosophy interviews, or maybe not. Some colleges combine them. I think normal would be separate interviews, and then maybe that adds up a bit. Sure. Can you question someone you didn't go to everyone else? Yes, I can do that. Is this the final MAT livestream? Yeah, good question. There it is. There we go. 691, and then we hit that. This is the last one in the series. We've done 20 something of these over the last few months, half a year, something like that. It's been really fun doing maths with you, learning about other maths problems, getting stuck on things. It's been nice to see you through the process as we learned about math problems and then interview problems and egg problems along the way. This is the last one of the year. In a couple of weeks, some of you got some interviews and then decision letters go out at some point. Oxford does another show in this slot from January to about June called the Oxford Online Maths Club, which is just like this, except instead of talking about admissions like math and interviews and things, we just talk about maths, interesting maths problems, not necessarily on the further maths specification. Good, okay. So we're going to be back for Oxford Online Maths Club in January. It is the common joke is that it is exactly the same as this, but with a different colour scheme and slightly different questions. There's a Spider-Man meme of it's the same but with different. Oxford does another show. James does another show. It's also hosted by me. I mean, at the moment. So I'm going to be back on the 4th of January with some on Oxford Online Maths Club. I've got an exciting season planned with some guest speakers, some current students, some interesting maths we haven't talked about before, and maybe a return of the egg problem, but let's hope not. If you want to see that happen, it was a bit of a mess. It was 2 weeks ago on the stream, previous live stream, for that live stream. Good, right, cool. Thanks for coming on. I'll see you in January. Best of luck with any interviews that you've got coming up. And best of luck with all of your maths. Bye. Enjoy December. Enjoy December? That's not something people say, is it? Happy holidays is something people say, or Merry Christmas. Nobody says enjoy December. From all of us here at the Oxford Maths Institute, wishing you a Merry Christmas, Happy New Year, happy holidays, and enjoy December. We'll see you in January for some other maths problems. Take care. Bye.